So 6.2a, we're going to start talking about some of the things that we know about parallelograms, and we'll move into some different figures as the chapter goes. But for today, just parallelograms in general is what we're going to be talking about. Do you know what a parallelogram is? When the lines are parallel, what kind of figure? Doesn't have to be a rectangle. A quadrilateral, right? It has to have four sides. So a rectangle is an example of a parallelogram, but it just has to be a quadrilateral with both pairs of opposite sides that are parallel. Okay, so a parallelogram will look something like this typically. If this is A, B, C, D, we would know that these two sides are parallel. Remember, we do the arrows for parallel and then double arrows for a different set of parallel. So that would represent a parallelogram, okay? Every single parallelogram has two sets of parallel lines, okay? The way we would write that is we would say AB is parallel to CD, and we would say BC is parallel to AD. Okay, so opposite sides are parallel. So there are a few theorems that we are going to do with parallelograms in general. The first one says this is Theorem 6.3. It says if a quadrilateral is a parallelogram, then opposite sides are blank. Okay, so we already said it's a parallelogram, so you can't say opposite sides are parallel. Any guesses what opposite sides are? How would AB and CD in that picture up above relate, other than being parallel, do you think? They're the same measure. They're congruent, right? So AB is congruent to CD, or BC is congruent to AD. So if a quadrilateral is a parallelogram, then opposite sides are congruent. Okay, and I mean, you could have a lot of different parallelograms that come from it, but as long as we know it's a parallelogram, the sides across from each other have to be the same. Okay, now if they don't tell you that it's a parallelogram, or they don't mark it for you, so a lot of times they'll mark it with these, or they'll just say this is a parallelogram. If they don't tell you that, then opposites don't have to be congruent, okay? But if they tell you they are, opposites will be congruent. So if opposite sides are congruent here, and we want to solve for x and y, what would you do for this example one? Set what equal? Right, so you could do y equals 4x plus 1, but you can't solve that one right now. So start with the one that has just the same variable. So you would say 2x plus 6 equals 3x minus 2. So if I take away the 2x, I have an x over here. If I add the 2, I have an 8 over here. So x is 8. And then you need to solve for y. And with solving for y, we're going to set these two equal to each other. So y equals, now we know what x is, so 4 times 8 plus 1. So I'm just plugging it in to that expression. So our y comes out to 32 plus 1, or 33. Okay. Questions on that? So opposite sides are congruent if it's a parallelogram. Okay. Consecutive angles. We've talked a little bit about consecutive angles, but I just want to make sure you're clear on what they are, because this theorem uses consecutive angles. So the definition of consecutive angles are angles that share the same side. So for instance, if I have a parallelogram that looks like this, this angle here, right, and this angle here both share this side. They both use that side to form the angle. Those are consecutive angles. Another way you could say it is same side interiors. Same side interior angles are consecutive, one right after the other. So, for instance, if I had angle 1, angle 2, angle 3, and angle 4, we would say 1 and 2 are consecutive, or 2 and 3 are consecutive, okay? So this theorem says if a quadrilateral is a parallelogram, then consecutive angles are, you should know this one, supplementary, right? Because they're same side interior angles. Same side interiors are supplementary. Back to chapter 3 there, huh? So if that's the case, in example 2 here, we want to find the measure of angle Q. What would you do? Right, 67 plus whatever the measure of angle Q is has to equal 180. They're supplementary, so just take away that 67. That means the measure of angle Q is going to be 113 degrees. Okay, so this would be 113. Now here's the deal. We have another theorem that's going to tell us more about this figure, but right now you should actually be able to find every angle in here with just that theorem. What would angle S be? 113, right? It's consecutive to this one, just like angle Q was consecutive to angle P. So they would be the same. So notice, what do you see with angles across from each other? They're the same. They're congruent. So that's the third theorem there. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so opposites are congruent, consecutives are supplementary. So what would angle R be up top? That would be 67, either supplementary to this guy or equal to the one across from it. Okay, so opposites are congruent, supplementaries, consecutives are supplementary. Okay, any questions on that? Okay, last thing is just a proof of why opposite angles end up being congruent. So the first part is your given, right? We take all this, that's our given. And then let's just draw a picture so we have something to refer to here. So if this is A, B, C, and D, first of all, the given is that it's a parallelogram. So I'm going to mark these as parallel and the second set as parallel also. Excuse me. Okay, so the reason we know opposite angles are congruent, it's not a super long proof, it's just, it looks long because you have 3 of the same thing for step 2 and step 3. So what we're going to say in step 2 is we know angle A and angle B are consecutive. Why do I know they're consecutive? We were told it right here, right? That's just the definition of consecutive angles. So that's all you need to write for that part of it is definition of consecutive angles. But with that, we're just going to lump a few other consecutive angles to get us where we need to be. So we know A and B are consecutive. We're going to say we know angle B and angle C are consecutive. And we know angle C and angle D are consecutive. Okay, because we know what consecutive angles are, we can say we know those are consecutive. Definition of consecutive angles. Okay, so if they're consecutive, then they're also what? Supplementary. So we're going to say for these next 3 steps, those same sets of angles, angle A and angle B and angle C, and angle C and angle D, we know all of those are supplementary. And I'm just going to do the little ditto marks. Do you guys know ditto marks? Just means we're saying the same thing as the thing right above it. So A and B are supplementary, B and C are supplementary, and C and D are supplementary. And that's because we know consecutive angles are supplementary. Right? That was theorem what number? Theorem 6.4. So if you want to write Theorem 6.4, that's fine, but that just requires you to memorize a number that you don't need to memorize. So we know those are all supplementary. So then our last step, we can actually say what they asked us to prove. Angle A is congruent to angle C, and angle B is congruent to angle D. Does anyone know why? If we know this pair is supplementary, that pair is supplementary, and this pair is supplementary, what do we... Right, so this is doing a proof of that theorem, so we can't actually use that theorem right now. But yes, we do know that opposite angles are congruent. We're just trying to prove why we know it. Do you remember if they are supplementary to the same thing, they are what? Congruent to each other, right? We learned that. I think that was chapter 3 also. So you just say supplements of the same angle are congruent. It was the congruent supplements theorem was the name of it. Congruent supplements theorem. Questions on that? Okay. That's what we have for today. You have a ton of time. This whole